You've probably heard the buzz, right? Generative AI is exploding, and it's got a lot of people asking a pretty huge question, especially in computer science. If an AI can write code for you, why even bother learning how to do it yourself? So today, we're going to dig into the actual data and see if this really is the end of programming class as we know it.
I mean, the promise is pretty incredible, isn't it? You just describe a problem in plain English, and boom, a large language model spits out a perfect working program. It's no wonder people are asking if we're at the end of programming. But, when researchers actually put this to the test, the reality, well, it turns out to be way more complicated and honestly a lot more interesting.
All right, so let's put ChatGPT to the test. How good is it, really, at actual computer science homework? Researchers threw a whole bunch of undergraduate-level questions at it. We're talking data structures, algorithms, the whole 9 yards. And the results, well, they were pretty surprising.
Check this out, 56.9%. That was its overall average accuracy. Yeah, just under 57%. The 2024 study that found this, by Joshi and his colleagues, they flat out called it highly unreliable. I mean, let's put it this way. If this AI were a student in your class, it would be failing, badly.
But, okay, that average score doesn't really tell the whole story. The AI's performance is all over the place. It swings wildly. You give it a nice, well-structured programming challenge, and it's like an A-plus student, 92.8%. But then you ask it to solve other kinds of problems, and its performance just craters, down to 39.5%. So this isn't some reliable genius. It's more like a flawed one. Absolutely brilliant at some things, and just bafflingly bad at others.
And this is where it gets even stranger. Get this. In one case, the AI correctly reasoned its way through a really complex problem, but then it just hallucinated an answer that wasn't even one of the multiple choice options. So it's not just that the AI is wrong, it's that it can be confidently and totally nonsensically wrong. And that is a huge, huge trap for a student who doesn't know any better and just trusts the output.
Okay, so we've established the AI itself is pretty inconsistent. But what happens when you actually put this powerful but flawed tool into the hands of a beginner? Let's switch gears and look at the real student experience.
So, before a student can even dream of getting a single line of code, they're staring at this, a blank box. And that first step, translating what's in your head into a precise natural language prompt, that is a massive hurdle. In fact, what's really fascinating is that studies show even when students know how to solve a problem on their own, they still struggle to describe it effectively to an AI.
And this right here, this is a super common sight. In one study, they actually nicknamed the AI tool Charlie. And, well, here, Charlie has failed. The code it spat out doesn't work. It doesn't match what was expected. Now, for a student, this isn't just a simple, oh, let me try again moment. It's a really frustrating dead end that can make them feel like they're the ones who aren't good enough.
Hey, that number looks familiar, doesn't it? 57%. But this time, it means something different. This is the average success rate for students who had already passed an Intro to Computer Science course. They were trying to use AI to solve problems at a level they'd already mastered, and even with multiple tries, they only got it right about 57% of the time. This thing is definitely not an easy button.
And this quote, man, this really gets to the heart of the frustration. See, these AI models are what you call stochastic, which is just a fancy word for random. It means you can give it the exact same prompt twice and get two totally different answers. And as this student, Kekibi, points out, if I'm not changing anything, why is that changing? How are you supposed to learn to get better if the output changes for no logical reason? It completely breaks the fundamental logic of how you learn to code and debug.
So, what all of this really shows is that talking to an AI is a skill all on its own. It's not a simple copy-paste job. Students struggle to describe the problem. They have a hard time understanding the code the AI spits out, and they can't remember the right technical terms to get good results. It's far from a simple shortcut. It turns out to be a really mentally demanding task.
All right, so we know students are struggling with these new tools, but what about the teachers? The educators are on the front lines here, trying to figure out the new rules of the game. I mean, what does cheating even mean anymore when a super powerful AI is just a browser tab away?
This is where it gets really interesting. A survey of computing instructors shows a pretty fascinating shift in thinking. You might expect them to just ban the technology outright, right? But they're not. Instead, they're developing this surprisingly nuanced view of what's actually learning versus what's just plain cheating in the age of AI.
And their thinking is actually pretty clear. Look at this. 95%, so nearly all instructors, agree that just generating a solution and submitting it without understanding it, yeah, that's cheating. No surprise there. But look at the drop-off. What if a student generates a solution but then takes the time to actually understand it before submitting? Now only 60% think that's unethical. And using AI to help fix a bug? Only 11%. So the line isn't really about using the tool, it's all about whether the student is just bypassing the act of learning.
So, how are educators actually adapting to all this? Well, the response seems to be breaking down into three main categories. First, they're changing how they test knowledge. Second, they're changing what new skills they need to teach. And third, they're changing where they focus the learning process itself.
And here's what that actually looks like in a new kind of classroom. For assessments, you're seeing a shift away from those classic take-home assignments and more towards things like oral exams or in-person coding interviews, where you just can't hide behind an AI. In terms of skills, they're actually starting to teach prompt engineering, the art of talking to an AI as a core skill. And maybe most importantly, the focus is moving away from just writing code to being able to read, understand, and critique it, no matter if it was written by a human or a machine.
So let's take a step back. The AI is flawed. Students are finding it frustrating, and entire classrooms are being redesigned from the ground up. What does all of this mean for the future of learning to code? Well, one of the biggest dangers researchers have pointed out is something they call the illusion of capability. This is a really important idea. It's the risk that students use AI to get the right answers, but they mistake that for actual learning. They feel like they're making progress, but in reality, they aren't building those foundational mental models they absolutely need to solve problems on their own later.
And faced with this huge risk, educators are kind of splitting into two main camps right now. On one side, you've got the resistance. They want to double down on the fundamentals and teach programming the old-fashioned way, in a space that's shielded from AI. But on the other side, you have the integrationists. They argue that's just not realistic. They believe their job is to integrate these tools right into the curriculum, to prepare students for an industry that's already using them, like right now.
So let's go back to our big question. Is AI the end of programming class? Based on all the evidence, the answer is no. But it is the end of programming class as we've always known it. The new core skill isn't just about writing code from a blank screen anymore. It's about learning how to collaborate with a machine that can be brilliant, buggy, and totally baffling all at the same time. The challenge isn't just learning to code. It's learning to question, to debug, and to guide this powerful new partner. So no, this isn't the end of programming. It's just a strange and a much more complicated new beginning.